in the last lesson, we spoke about the idea of an ogive, or maybe let's do a little recap first. So the real focus has been grouped data recently, and in group data, we always have like an interval into which the data falls. We have the frequency column, and then we have something called the cumulative frequency column. And in the previous lesson, what we did was we took these first two columns and we could make graphs. And the one graph that we did, where we had the intervals on the horizontal and the frequency on the vertical, was something called a histogram. And not the best histogram I've ever drawn, but get the idea. So that was the histogram. And then there was another, and that basically used these two columns. And then there was another graph we could draw called a frequency polygon. Can anybody remember, how did we connect up the histogram and frequency polygon? What was the connection between the two graphs? How did we get from the frequency from the histogram to the frequency polygon? Yes, the midpoints are key. So we need the midpoint of each interval. And then what else do we need? We need a little extra interval on each side to ground them. And then we need straight lines to join these midpoints. Yeah. And so this is called a frequency polygon. So those are two of the graphs you need to be familiar with for grouped data tables. And then at the end of the lesson, we started focusing on a graph that we can get if we focus on the intervals of data and the cumulative frequency column. And so this is called an ogive. And what this is, it shows information from a cumulative frequency table, and the graph is useful for estimating the median or the interquartile range of the grouped data. Something important to remember is that when we are drawing an ogive from a table, your cumulative frequencies are always plotted at the upper limit of the interval. So below here, I have a situation which we're going to use to draw an ogive first up today. And my intervals are sitting over here. Now, the upper limit of the interval is just going to be that value over there. And so when we are drawing an ogive, we have to remember that we use the end of the interval to plot our points. But to start with, let's make sure you know how to fill out the cumulative frequency column. So get me values for A, B, C, D, E, and F. And let's just make sure you know how to fill out this column, because that's the foundation of drawing an ogive. So the first one is a bit boring. Hey, it's like A has to be 5. And then that has to be 14. What am I doing? I'm just going 5 plus 9 gives me 14. Yeah. What's that going to be? I think it's going to be 31. Let's see, 80. What's the last one going to be? So what this is saying is up until 115 centimeters, there have been 80 students. And now if I want to go all the way up to 120, how many students will I have measured? I will have got 90. And so what this is telling us is this grouped data table has measured 90 students in total, because the column, the cumulative frequency total is 90. If I added up all of these items here, I would also get 90. And so in this exercise, when we talk about N, we know that N is 90 because there's 90 students who have been measured. Now, in order to draw an ogive, you need a set of points. So how do we get those points? And what I do is I just add an extra column for those points. And the way I get them is I go to the end of the interval. So I get 95 for the X. And then for the cumulative frequency, I write that down. And then the next one, I go to the end of the interval. And then I go, what's the cumulative frequency? And it's going to be 14. Can you fill out the next 4 points on the ogive for me? What are the next 4 points? I agree. So A must be 105 and 31. What about the next one? So the good news is at least it seems to be going up in a predictable way. And then over here, we've got that. So the good news is to draw an ogive, these are the points that I'm going to use. And so what I need now is I need a scale on oh, sorry, let me just take a copy here and I'll put it next to it so we can do this together. What I'm going to do is I'm going to bring out my, now you can make up your own scale and I encourage you to do that, but I'm going to use, this is from a past exam question. And so how do we begin to actually turn these points into a curve? So the very first one is 95.5. So let's, 95 is actually going to be there and 5 is going to be there. So that's my very first point. Now, one of the challenges is that because you are starting, you need to ground this. So what we do is we add one extra point at the beginning to make sure it gets down to 0. The point here would just be 90, 0. And what this does is it just grounds it over here. Then the next one, so we've done those two, would be 100 and then 14 over here. And then the next one would be 105 is in line there and 31 would be here. Can I ask you to take some time now to draw up a scale? It doesn't have to be exactly the same as mine, but roughly the same. I've done the first, well, 4 points. Can you do the next 3 and then complete your ogive for me? And then when you're done with that, just put 1 in the chat. I'm going to give you 2 minutes to do that because it takes some time. You have to draw up a vertical axis and a horizontal axis. And you're going to have to start at 90 and then have 100, then have 110, 120. And on this axis, you're going to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 0, 10, 20, 50. And what I want you to do is I want you to actually plot these points as I've done. So 100, I don't know, it's about 14, so it's about here. And then 105, 31, be up here. Okay, so I want you to do that and just take the time to do it properly at least once, because if you get this in a test, you can gobble it up with nice 110, 59, there we go. 115 would be here, and then 80, and then 120, 90. And so we have the extra point for grounding, and then we have 1, 2, 3, 6 more points. And the ogive doesn't have straight lines, it has curved lines. And so it actually looks like that. And that would be my ogive, simple as that. Now, one of the things that we said an ogive was good for was estimating the median. And that's actually what this exam question wants you to do. How do you estimate the median? Now, when we're normally finding the median, what do we do first? What's the very first thing that we do when we try to estimate the median? We find its position. Absolutely, Fazama, you are on the money. So we use that formula, which is going to be, because n is 90, my position is going to be 45.5. And if you imagine that on this axis is the cumulative frequency, where is 45.5 going to be? I think it's just going to be over here. So you draw a dotted horizontal line and get to there. Then when you drop down to here, that value is going to give you an estimated value for the median. So what do you think this value is going to be based on the ogive? Now you have to remember, you started this at 90 centimeters, and then you got to 100. 105 would be there. So what do you think that is going to be, that value? So I think it's going to be about 108 or 109. I'm going to go with 108. And what that is saying is, it's saying, look, in this group of students that we measured, 50% of them are going to be shorter than 108 centimeters, and 50% of them are going to be taller than 108 centimeters. It's the median. Okay. Give me a thumbs up if you followed that. Give me a thumbs down if that seemed a bit strange. I just want to get a quick vote from the people of the room so we know where we stand. Now, you can imagine that if I could estimate Q2, what if I wanted to estimate Q1, or the first quartile? So for those students who are feeling unsure, and I see in the chat there are a few, if I want to find an estimate for Q1, surely I have to first find the position of Q1. So what is the position of Q1, or the first quartile? Let's start with that. What formula do I need to use to find the position? Okay, Rafense, you're correct. You use this formula, and n is still going to be 90. And so now the question is, what is the position of Q1 going to be? So 22.75. Okay, now where would that be on my diagram? I have to go on the side here, and remember, it's the cumulative frequency side. If that's 25, 22.75 for me looks like it would be about there. And so Q1 would be somewhere around there. Now, if that was 105 and that was 100, what do we think the value of Q1 is going to be? Oh, sorry, things just changed into. What do we think the value of Q1 is going to be? Yeah, it looks to me like, it's closer to 105 than 103. So the value of Q1 is 103. Now, remember, this is an estimate. So I suppose instead of saying equals, I should have an estimate has these squiggly things. So it's approximately 103. All right, same idea. Could you get me an estimate for the upper quartile? What is Q3 going to be? What do you think? First we'll calculate the position and then calculate for me the actual estimate of Q3. What is the position of Q3 going to be? So 68.25 is the position. I think I agree with that. Lots of students. Linda agrees. Sate agrees. So that's good news for all of us. I think that this gets me to about there. Now, what is my estimate for the upper quartile? Now, I have to be careful because my scale is a bit dodgy, but if that's 110 and 1, 2, 3, 4, 5, so it's 2 per block. So 112, 113. Yeah, it looks to me like about 113 if I look at the, going up by 2 for each thing. So Q3 would be equal to 113 approximately. And there would be some leeway. Awesome. So we have an estimate. Well, there would be some leeway. We don't have to be exact because it's an estimate. But can you, as a final thing here, or second final thing, can you give me an estimate of the interquartile range for this ogive? What is an estimate of the interquartile range, or the middle, the area, well, the region where the middle 50% of the data is sitting? What do we think an estimate for the interquartile range is going to be? Now, we have to go back into our brains and remember what the interquartile range actually does. And I think Q3 would be 113. And what was Q1? Q1 was 103. And so the interquartile range would just be 10 centimeters. So what that's saying is that in this class, the middle 50% of the data are within 10 centimeters of each other. So then that kind of makes sense. If you imagine like lining people up in a class, I don't know if you've ever done this for photo day, but you'll see there's quite a lot of people who are quite in the middle and they're quite close together in height. They kind of just, they're always like fighting to say, oh, I'm taller than you, I should be ahead of you or whatever, because they're quite close. It's not easy to judge. Do we always use the x-axis? Yes. So because an ogive always has the cumulative frequency curve on the cumulative frequency on the y-axis, the position will always be on the y-axis and the value, whatever data you're grouping, will be on the x-axis. So that's always true, Cass. Now, you're doing so well, I can't help. So what would we get a question if it's off by 2 or 3 units? We normally allow 1 unit either way, but it depends on the accuracy of the graph that we give you. So yeah, I wouldn't be too good about that, but try and be as accurate as you can be. All right.
Mr. S.
Yeah.
There's a question where they say, why is Q1? Wait, yes. For Q1, why is the N40?
Why is the
N40 for Q1? But that doesn't make sense because it appears in Q2.
Yeah, there's no 40, so it's
or 90.
what happens Yeah, it's 90. So it's always 90. So I think that might have just been and that 90 comes from the N, the number of students who are kind of involved. So I think we're good for now. Cool. Okay, now I'm going to throw the word percentiles at you. If I said to you, I want an estimate for the 90th percentile. So we have to remember, what is that again? Well, it's a lot like a quartile, except like if the median is the 50th percentile and Q3 is the 75th percentile, the 90th percentile is just 90% of the way through the data. And the way we find it is we need to find the position of P90, which we use this formula for. Can you get me an estimate for the 90th percentile for this ogive? Can you give me an estimate for the 90th percentile for this ogive? What do you think? I'll give you some time to interpret that. Or if you have a question, pop your hand up and I can hopefully address it or help you. So let's do the working out for the position first. What do I get? So the position is going to be 81.9, but that's not the value of P90. The value of P90, I'll go to 81.9, which is here. I'd say it's just above that. What do we think the value of P90 is going to be based on the what the graph is telling us? So that was 110, so that's 112, 114. Yeah, it looked to me it should be about 115 centimeters. So P90 is going to be 115 centimeters, and that is an estimate based on the grouped data table. Give me a thumbs up if you feel like you understood how I estimated P90, and give me a thumbs down if you feel a bit lost. Okay. Now, what does that mean? It means that 90% of the students are 115 centimeters in height or shorter. And it also means that 10% of the students are taller than 115 centimeters. So that's how we interpret P90. It's telling us everything. What's below that is 90% of the data. What's above that is, the 10% above after that. Why is it 90 over 100? The reason it's 90 over 100, that's a great question. And you're referring to this thing over here. The reason it's 90 over 100 is because it's P90. So the position formula always takes the same way, like instead of writing a half over here, you could have written 50 over 100 for the median. It's the same as that. And you could have written 25 over 100 over here. It's just that it's easier to think of it in quarters. But when we think of the 90th percentile, we just think of it timesing it by 90 over 100. Will we always use a graph when looking for percentile? In Corsi, we did percentiles for the first time when we did lists of data. And so it is possible to use a list of data. And I would refer you back to video 2 or 3. But percentiles are not as common as quartiles. Quartiles are like the common one, but I'm just making sure I cover all my bases, especially that you've seen a good variety of questions. Okay, it's time for a break. We've done a good first half, but I want everyone to turn their cameras on, and I want you to stand up with me and be a bit silly. I want you to embrace your silliness, or maybe even your enthusiasm. Maybe silliness is not even the right word, but stand up and have a little stretch and make sure your cam is on. And for some reason, I can't see oh, there we go. I can see some video streams now. That's good. Okay. Let's start by just swinging your arms a little bit. So just loosen up and then shake your arm out, pretend you're a piece of licorice, and just take a nice deep breath. Okay. So let's start by loosening up by turning a little bit. So a nice narrow rotation. And then as you start to loosen up, you can extend your turning circle. Okay. And then shake out your arms again. Make sure they're nice and loose and flappy. And then let's roll our shoulders back. Let's do 5 rolls back. Roll 5, and let's do 5 rolls forward. 4, 5. Let's do this one. We stretch our arms across. Oh, that feels nice. I think there's an overworked muscle in my back. And then let's switch to the other side. Okay. Let's do some triceps. And let's do the other tricep. Okay, and then let's shake it all out. Okay, let's give our legs some attention. So we're going to try and do a hamstring stretch. So what you do is you stand on, have your hand nearby, lift your leg up and see if you can put your leg behind you and just stretch it up behind you, and you should feel a nice burn in your quad. Ooh, feels good. And then on the opposite side, legs behind you or leg behind you, and stretch. Okay, and then just take your legs out, just kick them out a little bit so that they're nice and loose. And then let us do some heart rate raising stuff. So we're going to do air skipping, and we're going to do 15 to 20 depending on how I feel. So 3, 2, 1, let's go. Yeah, 5 more. 5, 4, 3, 2, 1, and exercise time is over. I hope you feel like your body has had a bit of a break, and let's just have some fun before we get back to the main lesson. What is a Jedi plus a robot plus a fighter pilot equal to? Let me know in the chat. What do you think we're gonna? So that one must be 14, because 14, 28, 42, yeah. And that must be 14. So Lorenzo, I think that's meant to be like a Darth Vader or a stormtrooper or something like that from Star Wars. Oratile is on it, absolutely. That Luke, I am your father. That funny voice. So I think a robot thing would be 3. Oh, you guys already got the answers. Okay, well, let me see if I can catch up. So if that's 3, 3 times 3 is 9. That must be 9. That must be 3. And that must be 14, huh? And Bongokosi and Latabo and Linda, 14 plus 3 is 17. 17 plus 9 is 26. And so indeed, a Jedi plus a robot plus a fighter pilot is 26. Okay. I hope that you feel like you've had a break, so then we can return to the questions we were doing. So let's look at another exam question. Okay, so this one is a little bit different. This one is, step 1 is, I want you to take this histogram and draw your own grouped frequency table from the histogram. And when you are done, just say done in the chat. So can you create your own grouped data table by looking at the histogram? Over to you. You lost your pen. Can't have gone far. Can't have gone far. So I guess I first need my intervals, or my class interval, and that. Okay, so step 1 is the intervals. Then I need frequency, and then I need cumulative frequency. But these must be the frequency counts. So 12, 18, 55, 57. So that's actually pretty straightforward. The one that takes a bit of work now is to work out what the cumulative frequency column is. But what I'm doing is I'm saying that the first one is 12, the second one is 12 plus 18. So see if you can get the rest of my, I might need to use a calculator myself because I think my brain is also having end of the day fatigue. So 30 plus 55 is 85. And then, so 142. And then 185, 196. And that makes me very happy because at the beginning of the question, they said there were 200 students whose marks they were analyzing. And the fact that my cumulative frequency is 200 means things have gone well for me. All right, now, in order to draw an ogive, the next question is, I have to draw an ogive to illustrate the data in the frequency table. Now, what I did before is I added an extra point. And what this point was, is it was made up of the items that go onto my ogive. And the thing that you need to remember is what? When I draw my X value, what's my X value going to be to start with? What's my very first X value and what's my very first Y value going to be for the points that go on my ogive? That's the thing we have to remember. So yeah, it has to be the end of the interval. So this is going to be 40, and that's going to be 12. Now, you're right, Profensi, that there actually is a sneaky one, the grounding one. So in some ways, you could say that there's a little point before, which would be 30, which you're absolutely right. You can just add this on the graph, but perfect. And then the next one would be 50, 30. And the next one would be 60, 85. I want you guys to fill out the next 3 points for me to make sure you can generate those points all by yourself, looking at the grouped data table. So just tell me done when you've worked out these 3 values. Okay. Oops, there is it. And then what I want you to do is I want you to draw up a cumulative frequency scale where you go all the way up to 200 on the vertical, and then on the horizontal, you have your marks, which you are playing with in this question. And I want you to start drawing your ogive. So the very first one, I mean, you could go 40, 12 first. So there's 40 and there's 12. We know we need a grounding point, which is going to be here. And then we have 50, 30. So 50, 30. I want you to complete these points and then begin to put them on your own ogive. And start to draw the curve for yourself. And then once you've put your dots, I want you to connect up the dots in the correct way to complete your ogive.
Mr. S. Nokubonga is asking that may you please scroll down. They can't see the X intervals.
Aha, thank you. Cheers. What I have at 9196. So that should actually be a little bit more. Okay. So I hope that you can see that at the moment. Now, what I want you to do is I want you to get me an estimate for the median, or get me an estimate for Q2 by using your ogive. And remember that when we started this, the n value was 200. So estimate what Q2 is for me. I'll let you use what you've seen so far in the lesson today. So remember, with the median, you start by looking at the position. And the position would be 100.5 maybe. So where would 100? Let's use a different color. 100.5, it's probably a little bit over. No, it feels to me like it's going to be about 65. Like, I mean, it's not perfect, but yeah, I'm going to say approximately 65%. So that is going to be the median. So 50% of students scored below 65 for their counting exam, and about 50% of students scored above 65. So I would say, from a teacher, that's actually quite a good mark. Like, you know, when you've got half your students scoring above 65, that's quite a good result. Now, give me a thumbs up if you're feeling okay, because I want to tackle a more detailed question, but I want to make sure that we are all together. How can we get the accurate median? It's not possible to get a perfect median because it's grouped data. The moment you have grouped data, you give up some accuracy and you have to estimate, because you only know it's in an interval. You don't know the exact value. But that's why the ogive is so useful. Okay, so let's tackle question C. Use the ogive to estimate how many learners scored 72% or more for the examination. So where should I go and look for this? So I need to estimate how many learners scored 72% or more, but I'm thinking, let me go and find 72% first. So if I go, where is 72 on, let me get a different color so that I stand out. I'm going to my marks and I get to 70. So 72 would be about here, let's say. What do you think goes with 72 if I go across to the vertical axis? What do you think is going to go with 72? It seems to me like it kind of goes with about 140. Now, the question says, use the ogive to estimate how many learners scored 72% or more for the examination. How many do you think scored 72% or more? What do you think the correct answer is? I'll be a little bit, it's a sneaky question. So I'll ask you this. How many students in total were there in the examination? So how many students in total were recorded, or results were recorded? I think it was 200. And I can see the 200 here. And I want to know how many students scored 72% or more. Now, what I think the ogive is telling us is that 140 students scored 72% or less. But I want to know how many students scored 72% or more. And I think that is the difference between how many there are in total and how many scored 72% or less. So what is that difference going to be? I think the difference is just going to be 200 in total minus 140, you got 72% less, which means 60 students got more than 72%. Maybe about 56. Yeah. Linda, you're absolutely perfect. Absolutely perfect. Now, just to extend this question a little bit more, if I said to you, how many, this is like a higher order question, how many students got 90% or more for this exam? Could you answer that question? How many students got 90% or more for this accounting exam, using the same idea that I've just shown you now? How many students would have got 90% or more? So I think we probably want to find 90 to start with. That's where we're going to start. Now, how can we work from that and work out how many students got 90% or more? Well, I think I have to go up, and I get to about there. And then if I go across here, it looks to me like it's in line with about 195. Now, that means that 195 students got 95%. Oh, sorry. If it's in line with the 195, it means 90% of students got, wait, how do I say this? Basically, 195 students got 90% or less. So how many got more than 90%? Well, in total, there are 200. We know that 195 got 90% or less. So how many got more than that? It's going to be 5 students. It sounds like a bit of a mouthful. Even I was getting a bit tongue-tied there, but I hope that the idea that I'm trying to show you is coming through. Can I have a quick little thumbs up if you feel like you're following this? This is a hard question, but just want to get a quick little sense of how we're feeling. Okay. Okie dokie. Well, let's see. That is a hard question. So I would recommend that if you feel unsure, go back and rewatch that part of the recording. And I promise you it'll make a bit more sense. Let's see if I can squeeze in one more question here. Let's see if we can do, let's do this last one here. Okay. So it says, and this is a common exam question as well, the masses of a random sample of 50 boys in grade 11 were recorded. The cumulative frequency graph represents the recorded masses. So here's the question. How many boys had a mass between 90 and 100 kilograms? So how many boys had a mass between 90 and 100 kilograms? Where do you think you have to look? So I'm going to go, and then so the one, or for the red one, it's going to be 28. It looks like to me. And for the blue one, 42. So how many boys weighed between 90 and 100? We just go 42 minus 28, which is 14. Yeah. So A's answer would be 14. Can you estimate, it's also 15 or 16 would have been fine as well. 1 degree, one above or below that would have been completely fine. Can you estimate the median mass of the boys using the ogive that you're given? Can you estimate the median mass of, there's 50 boys in total. What's the estimate of the median? Oh, what have I got? About 88, 89 is what I'm getting. So let's go with 88 kilograms as the median. So that is some pretty heavy boys. I mean, I don't know what, yeah, that seems pretty chunky to me, but maybe it was a rugby team or something. Oh, it was a, yeah. So last question for the day. Estimate how many of the boys had a mass less than 80 kilograms. How many boys have mass less than 80 kilograms? See if you can do that. Okay, be careful how the question is phrased. So it says less than 80. So this isn't as difficult as the one I just gave now. This is just saying what goes with 80, it's 15. And we know that 15 boys are going to weigh 80 kilograms or less. So that would be 15. If I had to ask you a follow-up question, how many boys weighed more than 80 kilograms? What would you say to that? What would the answer be for D, the made-up one? How many boys had a mass more than 80 kilograms? Well, what is the total involved? It's going to be 50 in total. We know that there are 15 that are less, so the ones that are more must be 35. Sate, what is your question? I see your hand is up. How can I help?
I wanted to ask if is it possible that they might ask us to give them an outlier.
Okay, so an outlier, we spoke about it briefly. We spoke about how, in a previous lesson, about how to recognize what an outlier is, but an outlier is not very common in this type of question. In fact, off the top of my head, I can't think of an outlier being relevant at all. Okay, so it's just not very common in this type of question. All right, everyone, that is so I hope I answered your question. That is the end of today, and